Today, we are going to learn section 512, solving equations by factoring. So, one of the things that we will notice that is different is throughout chapter 5, we've been dealing with expressions. We've been dealing with things that look like this. We've been dealing with things that look like this. We've been dealing with things that look like that. And notice that those are expressions, there's no equal signs. So we're going to move towards equations now. So these expressions will now have an equal sign, which will turn them into equations. So we've been dealing with solving for variables. When we have equations, when there's an equal sign, then typically we want to solve for the variable. And the variable in this case is we want to solve for x. And so this is very basic. This is a one-step equation that we should be familiar with. We want to isolate the variable. What is happening to the variable? We're trying to get this variable by itself. So we look to see what's happening to it. 4 is being added to it. So we will do the inverse operation. The inverse of adding 4 would be subtracting 4. And we end up with x equals 2. And this is the solution. We call that the solution. There's only one number that can go in for x that would make the left side equal to the right side. So if we plug that in, you start off with this equation. And if we plug in the 2 and simplify that left side, we get the left side ends up equaling the right side. So that's why we know that this 2 is a solution to this equation. Now the equations begin to get more complex. We have two-step equations where we have to do more than one step in order to isolate the variable. But again, we're still solving for the variable. So we would get rid of things being added and subtracted first. And then we would get rid of multiplication. Inverse of multiplication is division, and we get x equals 6. That is considered the solution to this equation. It's the only number that can go in for x. If we tried to plug in 7, sorry, that's minus. If we just tried to pick any other solution and we tried 7, that would be 14 minus 5. And 14 minus 5 is 9, and we notice that the left side does not equal the right side. So 7 cannot be a solution. The only number that works would be 6. So we found that when we were doing problems for a while, that we saw each time we would come up with only one solution. Remember that time, all of a sudden, when we were given two variables, we found out that, oh, wow, now we might end up with multiple solutions. Not only multiple solutions for the single variable, but multiple solutions for both variables. So if we look at this, if we tried to solve for x, we would get this equation, right? We would subtract y, and we get x equals negative y plus 6. So remember when we isolated for the variable, we only got a constant, because there's only one variable in the equation. However, when we introduce a secondary variable, you notice that when we solve for x, we get another variable in our solution. So that doesn't really help us because it doesn't give us a constant. It's not a true value. It's not a value that we can work with. So we have to be careful about that in the sense that it makes it more challenging when we have multiple variables or different variables. So however, we did solve this. Remember, what are solutions? If we think about this mentally, right, you could have 1 and 5. And remember, our solutions ended up being on a coordinate plane. You could do 1 and 5, 0 and 6. You could do 2 and 4. You can do negative 3 and 9. You could do 1/2 and 5 and 1/2. And we found that there were an infinite number of solutions. That there's no one solution. Much like this, there was only one number that we could plug in that ended up being the solution. when we had multiple variables, there tended to be an infinite number. And what we did in order to show all those solutions is we graphed it on a coordinate plane, and that was that's how we showed that infinite number of solutions. So here is what we've been working with. This is what we're going to be introduced to today is, well, first of all, remember we've been working with expressions. And so now that we put an equal sign in here, what is the detriment here? What is the thing that's holding us up from solving for the variable? Because that's what we're doing. We're solving for x. We're still solving for the variable x. Can we isolate x? And in this problem, because we have a square, and to the first degree, we have the same variable, but unfortunately, one is to the second and one is to the first degree. So we can't isolate that at the moment. Those are different. These are not like terms. These are different, so we can't combine them, and we can't solve for it because we can't really deal with both of those differences. Those are uniquely different variables because one's being squared and one is to the first degree. So we got to revert back to, well, why did we do this? Why did we factor all those? Well, there were a couple of reasons that it was beneficial factoring. Factoring turned addition and subtraction to multiplication. But we're also going to see one other benefit of factoring. So when I asked you to factor this left side, and we're just going to factor this part, the left side of the equation, we're going to change it. So we go through our criteria. Does it have a greatest common factor? No. Is it the difference of squares? No, it has 3 terms. Is it a binomial square? All right, it has 3 terms. Unfortunately, the second sign is negative, so it's not a binomial square. Can we do a times c? Yes, it has 3 terms. So a is 1, c is negative 6. Factors of 6 are 1 and 6. So factors of negative 6, well, where's my pen? Sorry about that. Are 1 and 6, 2 and 3. We know that the signs are different. When that is a negative, we know the signs are different. And then we look at the first sign and we see that the bigger of these 2 factor pairs are going to be positive. So the bigger is positive, the smaller is negative. Bigger positive, smaller negative. That makes 5, that makes 1. We look to see which one of these equals my middle coefficient, and that would be negative 2 and 3. So we're going to break this down to, we're going to change this from 3 terms to 4 terms by taking those 2 factor pairs and substituting it in for this value for the middle. We know that this simplifies back to this, so we haven't changed the equation. Notice I said equation because it's not an expression anymore. We bring that down. Now we're going to factor by grouping. We're going to factor out an x from the first pair. We're going to factor out a positive 3 from the second pair. And now we are going to factor out the negative 2 because it's being multiplied by both of these. And when you take that away, you're left with x plus 3. So there's a couple benefits that we just accomplished here. Remember, this is my starting equation. And what I didn't like about it was the fact that I had the same variable but 2 different exponents. And that is that's troublesome for us. We can't isolate the variable. But if we look here at after we factored it, we turned it from that equation to this equation. Hey, look at this now. Notice that we have like variables and to the same degree. So that helps us big time. So now we are able to isolate it by using some other math techniques. So that's the big concept here, is we got to take that polynomial and turn it into products, or we have to factor it. So let's move on to the next concept that we have to address. Oh, and those need to be 12s, not 20 and 36, sorry. Let's change that. That's a 12. That is a 12. All right, so we have these two unknowns. You've got the green box, you got a green box, and we want to know what two numbers multiply to make 12. Well, you can put 1 and 12. Give me another pair of numbers that multiply to 12. Well, you can have 2 and 6. How about a third one? Oh, I can actually do -4 times -3. And here's even crazier is we could do 1/2 times 24. So how many numbers can go into these boxes in order to multiply to 12? Well, there's an infinite number of numbers. We could do a quarter, we could do negatives, we can do all these other ones, okay? So there are an infinite number of numbers that we can multiply that their products equal 12. So there's nothing that I can or I can assume. Let's move this one over. There's nothing that I can assume if I have an unknown times an unknown that equals 12. There's nothing that I know about these boxes. It can be any number. Let's look at when it multiplies to make 0. So let's find 3 examples. Well, 5 times 0 equals 0. 0 times -2 equals 0. And 1/3 times 0 equals 0. And I can keep making pairs, and I can keep doing two numbers that multiply, and what we'll notice is that each one will always have a 0. That one of those two numbers, if I multiply two numbers that equal 0, I know that either x equals 0 or y has to equal 0. One of these two has to be 0. That's the only way that when you multiply two numbers you get 0 is we know that one of them is going to be 0. So when I have these two boxes, these two unknowns, and I know that when we multiply them that it equals 0, I know that either this box needs to equal 0 or this unknown needs to equal 0, right? We know that. Either this box has to be equivalent to 0 or this box has to be equivalent to 0. So let's look and see what is underneath this box. Oh, there's an x. Okay, so this has to either be equal to 0 or, let's look what's underneath this box. X plus 3. Okay, so then x plus 3 has to be equal to 0, right? Whatever is underneath there has to be equal to 0 because we know that the product of those two, the only way it's equal to 0 is if this is equal to 0, which we write like this, or if this is equal to 0. So how do I make this box, the x plus 3, equal to 0? Well, we set it equal to 0. We say x plus 3 equals 0. What is the value of x? So we're going to solve. It's a one-step equation. So 3 is being added to x, so we do the inverse of adding x, which is subtracting x. And we find out that x equals -3 or x equals 0. So when x equals 0, we know that that's where the 0 is. If x equals -3, we know that's going to make this box 0. And if either of these boxes are equal to 0, then we know the equation is equal to 0. So those would be the solutions. And let me show you a little bit more on what I mean by that. So we have this equation, x times x plus 3 equals 0. So we're saying one of the solutions is when x equals 0. So let's plug in a 0 for x. Is it a solution? Well, 0 plus 3 is 3. And then 0 times 3 equals 0. Oh, yeah, so that worked. The left side equaled the right side. So that was when x was equal to 0. Now let's see the equation when x is equal to -3. So we're going to plug in -3 in for x because we're saying that that's what the solution is. So let's simplify. -3 plus 3 is 0. -3 times 0 is 0. And again, the left side equaled the right side. Remember when we did our first couple of problems? Remember that when we plugged it back in, that left side equaled the right side. Right? When we plugged the solution back in right here, we plugged the 2, this is my solution, I solved for the variable. When I plugged it back in, it made the left side equal the right side. So when we have this, here's my problem, right? When we have that, so these are my solutions. The way that we notate our solutions, so our solution is x equals 0 and x equals -3. So we write these little squiggly, that's a solution set, and we write our solutions, our two solutions, in numerical order. So that's what you would write as your solution to this equation. So let's look at the next one. So again, we have two boxes. We've got two terms, two unknowns. We've got this unknown times this unknown. And notice we have parentheses, so that has to be connected together. So either the green box is equal to 0 or the blue box is equal to 0. So how do we find out what value? We set each box equal to 0. So the green box is just x. We set that equal to 0. The blue box is x minus 7, and we set that equal to 0. This has already been isolated. X is by itself, so we don't have to do any work. That's one solution. X is not isolated here, so we have to get rid of that -7. So we add 7, and we're left with x equals 7. So my two solutions to this equation are 0 and 7. Notice it's in numerical order, smallest, largest. Let's look at another one. Now it looks like a professional problem. So we have two boxes. We have V that sets equal to 0, and we have the V plus 1 that we're going to set equal to 0. That's isolated. I'm going to subtract 1. We get V equals -1. My two solutions are -1 and 0. Notice I put the -1 first because it's smaller. Numerical order, small to big. So let's take a look at this one. I would like you to pause the video and set each of those equal to 0, isolate them, and then write your solution. When you're ready, push play, and we'll go over the solutions. Okay, so the first thing you do is you set one of them equal to 0. You set your other equal to 0. This is already isolated. We are going to subtract 6. A equals -6. And my solution set is -6, 0. And there it is. As easy as that. So let's look at one more. So again, we set that term equal to 0. We set this box equal to 0. Already equal to 0. Add 7. P equals 7. And we get 0 and 7. All right. Let's put a little flavor on it. So notice our boxes are a little bit bigger. But remember, this box has to equal 0 or this box has to equal 0. And whatever's in that box. So whatever is in that box needs to be equal to 0. What value for this box would make this equal to 0? So when we say V minus 1, that is going to have to equal 0. What value can you put in for V? Well, instead of thinking about it, we do it mathematically. So we set this one equal to 0. And then we look at the other group and we set that one equal to 0. So we're going to isolate it. So we see that when v equals 1 in this left box, 1 minus 1, that's when it equals 0. That would create a 0 in that box. That's what we're doing when we do that mathematical part. If we subtract 6, v equals negative 6. Notice that when we plug in a negative 6 for here, that would make that box equal to 0. Negative 6 plus 6 gives me my 0. So that would make the equation equal to 0. And that's what we're doing. We're just finding out what value makes a 0 on the left side, what value makes a 0 for the right side. All right, so my solution is going to be negative 6, 1. Oh, notice this one. So again, I'm going to give you a second. Pause the video. Take a peek at this. Set them equal to 0 and solve for them and see what you get as your solutions. When you're ready, push play. So we have our first box or quantity that's going to be equal to 0. Then we have our second box that we have to find out what makes it 0. So we're going to solve. This is a one step. We get b equals negative 8. That's real easy. And this one, oh, now this is a two-step problem. So with a two-step, we always get rid of whatever is being added and subtracted first. And then we're going to divide. And b equals negative 4/7. So there are our two solutions. How do we write that? Numeric order, negative 8 is smaller than negative 4/7. So the bigger always goes to the right. This one, a little bit different. A little bit different in the sense that there's a coefficient in front of the variable. But we still have two boxes. And we're going to still set each box equal to 0. So 2n equals 0. We're going to divide by 2. Isolate the variable. 0 divided by 2 is 0. We're going to add 8. N equals 8. And so my solution set is 0, 8. Those are the two values. When plugged back into there, make that equation true. That's what that represents. Last one that we're going to discuss. This is a nice, fun, challenging one. Now, a lot of students, all of a sudden, they forget about setting everything equal to 0. And they look at this square and they think, oh, I have to simplify that. And they'll either do this incorrectly. They'll write a squared plus 16. That's not what this simplifies to. Remember, a plus 4 quantity squared is a plus 4, a plus 4. So we would use FOIL. You get a squared plus 8a plus 16. But what's wrong with that? Why don't we want to do that? Because notice what happens when we simplify that. We get two variables with different exponents. And that's bad. That moves away from what we are trying to do. So don't simplify this. We like the fact that it looks like this. And we're going to use this idea of it. We're going to rewrite this out. We're just going to write it as 2 times a plus 4 times a plus 4 equals 0. And all that says is, hey, you have 3 boxes that you are multiplying that equals 0. That's the only difference. That's the only thing that this equation has done, is now you have 3 numbers that you're multiplying that equals 0. So you have this mystery box times this mystery box equals 0. So we still know that this could equal 0, this could equal 0, or this could equal 0. So we set each one, oh, didn't mean to do that. So we're going to set each one equal to 0. We're going to say, okay, let's find out what's in there. Well, that's a 2. 2 equals 0. Let's look and see what's in there. A plus 4. What's going to make that 0? And then you take this one, and that also is a plus 4. So notice we still set each one equal to 0. Delete, delete, and delete. So let's look at this first one. First of all, there's no variable. And Can 2 equal 0? No. So that gets just thrown away. That's not a solution. Here's my variable. I'm going to minus 4, and I get a equals negative 4. That's one solution. Here's a variable. I'm going to isolate that variable, and that also equals negative 4. So when I write my solution, I just want the number or numbers that are solutions that can plug in to make 0. So I just write negative 4 once. I don't have to write it twice because it's the same number. I want to know the solutions. So in this example, there's only one solution. So that constant, when you have a constant out there, that actually doesn't even come into play. That gets negated. That's the word I wanted to use. All right, so hopefully you understand these concepts, and we're going to utilize the fact that two numbers multiplying equals 0 provides a good thing for us. And we're going to take advantage of that because we know that one of those values must be equal to 0. Come and see me if you got questions.